بسم الله الرحمن الرحيم. صباح الخير، حياك الله زائرنا الكريم في كبك وفي مرفأ استيراد الغاز المسال. لعلي أستوقفك قبل استئناف زيارتك لأعرفك بمهمة المجموعة ورؤيتها، واللي تتمثل بسعينا لأن نكون روادا في مجال الغاز المسال، وأن نزود دولة الكويت بالطاقة بما يراعي الاستدامة البيئية. مرفأنا من الأكبر في العالم، مزود بأحدث ما جاد به التقدم العلمي والتكنولوجي من معدات، وبفلسفة تشغيل لا تحيد عن أعلى معايير الأمن والسلامة، لضمان إمداد مستدام يلبي احتياجات متزايدة للطاقة في دولة الكويت. إن أمنك وسلامتك أولوية قصوى لنا، لذا أرجو منك التقيد باحترازات الأمن والسلامة واللي سنعرضها لك بعد لحظات. وختاما أشكرك لكريم انتباهك والتزامك، وأرجو لك يوما سعيدا وزيارة مثمرة.
Here in the LNGI terminal, we take pride in being committed to the HSSE precautions, and that's why we ensure that no access is granted to the site unless proper induction is provided. We also make sure that unauthorized photography devices and mobile devices are confiscated prior to entering the site. We also make sure that smoking and flammable materials are not allowed.
Whenever you are driving inside, make sure to wear the seat belt and abide with the speed limit.
One of the most important aspects of safety is personal protection. And whenever at site, there are safety protective equipment that needs to be worn at all time, one of which is the safety shoes, protective glasses, and the helmet. There are personal protective equipment that are case dependent. For example, whenever you are in the proximity of marine operations, life jacket becomes a must.
Kuwait Integrated Petroleum Industrial Company has built a new LNG regasification plant through Al-Zour LNG Project (LNGI) to supply natural gas to Kuwait natural gas grid. Liquefied natural gas (LNG) is the liquid form of the cleanest burning gas used in homes and industry every day for heating, cooling, and cooking. Kuwait LNG plant is the largest single facility to cover both export and import operation. The terminal is designed to unload LNG from the LNG carrier at desired rate of 7,000 m3 per hour. Utilize 3 LNG loading arms for each berth. To transfer natural gas into LNG, LNG liquefaction process cools the gas to -162 degrees Celsius. The resulting LNG is colorless, odorless, non-corrosive, and non-toxic. The marine facility, Area 10, there are 2 jetties for terminal unloading requirements. Jetty 1, which is capable to receive LNG ship of size 122,000 to 266,000 m3 for unloading in Jetty 1. Jetty 2, which is capable to receive LNG carrier size of 80,000 to 266 m3 for unloading. Prior to the ship arrival, the terminal begin preparation to receive the cargo by ensure optimum process parameter. During the LNG ship arrival and successful breathing and mooring operation, communication are established and unloading arm are connected. LNG is pumped out from LNG ship to the terminal through the liquid unloading arm. The unloading system consists of 4 unloading arms in each jetty. 3 are meant for LNG unloading and 1 is dedicated for boil of gas return to the ship. This is to avoid vacuum pressure inside the LNG ship. Finally, the LNG is transferred from the jetty head to the storage tank through the pipeline.
I will talk about Area 20, which is also known as the tank area. In total, 8 storage tanks of 225,500 m3 net working capacity have been considered for the LNGI reception and storage. The tanks provide 12 days of autonomy for the maximum send-out, which is 3,000 pptu per day, without receiving any LNG carrier. The storage tanks are full containment type, with a freestanding 9% nickel inner tank mounted in a concrete outer tank with pre-stressed wall and a concrete roof. The annular space and suspended deck are fitted with expanded perlite thermal insulation. This insulation limits the maximum boil-off generation rate to 0.05% per day of the tank volumetric content. Each tank is provided with 2 filling lines to achieve optimum mixing between LNGs with different composition. The filling mode depends on the quality of the stored and the unloaded LNG. During normal operations, tanks store the LNG, and the space at the tank top holds the vapors generated due to the tank heat leaks, which is called boil-off gas. Depending on the terminal operating mode, tank pressure is maintained with the BOG compressors. The LNG storage tanks are provided with control and protection systems in order to prevent tank overfilling, LNG certification, overpressure, and vacuum conditions. Alarms and shutdown devices have been incorporated to provide maximum safety for the tanks.
This vertical vessel behind me is the recondenser. It is the process unit that is responsible for the zero flaring philosophy of the terminal. In this vessel, compressed boil-off gas is mixed with LNG in a ratio of 1:10 to recondense and return the boil-off gas back to liquid to avoid any losses and flaring. Here we have the high pressure pumps. They are canned, centrifugal, and fully submerged in LNG. They operate to increase the pressure of the incoming LNG up to 56 bar to satisfy the pressure requirement of the national grid.
Behind me you can see the BOG compressors and the shelter. The main purpose of the BOG compression system is to handle the BOG generated in the LNG storage tanks. In order to maintain the pressure in the system and achieve zero flaring, the BOG compressors withdraws and compresses the excess BOG generated in the system and redirected it into 2 main systems. The fuel gas system, where the BOG is utilized as an internal fuel source, or to BOG recovery system, which recovers the BOG back into LNG in the recondenser. We have 4 BOG compressors in the LNG terminal. The number of BOG compressors in operation can vary depending on the operations of the LNG terminal. 1 out of 4 BOG compressor can be considered as a backup.
Kipik's LNGI terminal is an LNG regasification facility. Therefore, it is equipped with 2 different types of vaporization system. The main being ORV, open rack vaporizers, where seawater is used as the main heating medium to regasify LNG. The heat transfer occurs between the seawater and LNG flowing in aluminum finned tubes. The seawater used is pre-treated to avoid any biofouling and maintain acid integrity. Once completed, the seawater is collected and treated again prior to sending it back to the sea. The other type of vaporization system in the terminal is the submerged combustion vaporizer, SCV. This system is used as a backup only. The vaporization mechanism in this system happens by the flow of LNG in stainless steel tubes submerged in a water bath, which is heated by a combustion reaction between fuel gas and air. In order to comply with the temperature requirement of the national grid, the terminal is equipped with natural gas trim heater. This system only operates during the colder season when seawater temperatures drop. This system operates to provide the heating duty required to increase the natural gas send out up to 20 Celsius.
Metering station. Metering station is a system that will calculate the volumetric flow rate and provide analytical measurement of gas composition by utilizing subsystems. Actually, in our metering station, we have 2 subsystems are sending the natural gas to 2 destinations, Kipik, Mina Abdullah refineries and KUC pipeline network. Kipik and Mina Abdullah refineries is prioritized over KUC network. In Kipik, Mina Abdullah refineries, we have 2 runs, and in KUC we have 5 runs sending the natural gas to KUC pipeline network. As well, we have 2 gas chromatograph systems in order to measure the quality of the natural gas send out. Then the natural gas send out will pass through booster station. The booster stations are compressors stations which are an integral part of pipeline network in order to move and maintain the quantity of the send out based on the required pressure.
LNGI terminal aims to achieve zero flaring to the atmosphere in order to reduce carbon footprints and avoid causing any harm to the environment. However, due to emergency or abnormal operational conditions, the flare package is essential and required to be used in order to collect and burn all excess boiled-off gas and natural gas discharges from the terminal that could not be recovered or internally consumed. The flare system mainly consists of one LP flare header, which is for the low-pressure discharges, and one HP flare header for the high-pressure discharges, and finally 2 flare knockout drums to prevent any liquid or droplets to enter the flare system in order to avoid any hazard.
Area 17, Utilities Area. In LNGI facility, there are a lot of utilities for either building or process need, such as nitrogen, which is used for continuous purging and sealing, continuous valve control, regular draining of process equipment, plant maintenance, and also for initial cool down. Instrument and plant air. Instrument air is used throughout the LNGI terminal as the medium for pneumatic instruments, control valves, IPS valves. Plant air will be used for general cleaning of equipment and facilities and to distribute air power for pneumatic tools and air-driven equipment. Sea cooling water. Seawater is used instead of air compressor cooling system. Firewater. Firewater, there are 2 sources of firewater, seawater and distilled water. Distribution systems are applied to the terminal. A seawater supply system shall be provided for control and suppress any fire that may occur in the process units, tank farms, and jetty of the terminal. A distilled water supply system shall be provided for inside buildings such as fire station, M&O buildings, warehouse, workshop, and the administration building. Seawater. Seawater is the primary heating medium for vaporizing the LNG. Seawater will enter the intake station and pass through series of screens to remove marine debris. Chemicals. A lot of chemicals are used. The most relevant chemical to the process are the following: sodium hypochlorite and sodium bisulfate.